This massive black hole is consuming matter at an unprecedented rate, swallowing an equivalent of 1 Earth per second on its path. An Australian team of scientists thinks they've located the black hole with the highest growth rate in the last 9 billion years. All thanks to the Coonabarabran telescope, scientists have found a very bright object that is powered by a supermassive black hole. Astronomers measured the black hole's growth and found that it was like nothing they had seen. And it's been growing at an impressive speed for 9 billion years, and it's estimated that its mass is equivalent to 3 billion suns. A 1.3-meter telescope in Coonabarabran, New South Wales was used for the SkyMapper Southern Sky Survey. This telescope found a quasar, a very bright object powered by a supermassive black hole. According to calculations, the black hole called J1144 is 7,000 times brighter than all of the Milky Way stars. So let me say it again, 7,000 times more than our entire Milky Way combined. The study's principal author, Australian National University astronomer Dr. Christopher Onken, estimated that the black hole was halfway across the galaxy. In addition, he said that it took the black hole's light 7 billion years to make its way here. The most recent estimates say that it's been almost 13.8 billion years since the Big Bang. So, imagine this black hole has been getting bigger every light year since the Big Bang. The study's authors claim that for the last 9 billion years, J1114 has been the brightest quasar. If we compare this black hole to Sagittarius A, which is just 30 times broader than the Sun and located only 27,000 light-years away, Sagittarius A is small. The supermassive black hole at the center of an active galactic nucleus is the source of the quasar's bright light. With a mass of 3 billion times that of the Sun, they calculated that J1114 is around 500 times larger than the supermassive black hole at the center of our Milky Way galaxy. In their study, co-authors led by Dr. Christopher Onken describe it as a pretty huge, unexpected needle in a haystack. Some black holes have the same characteristics, but as several scientists concluded, they all tend to be much earlier in the history of the universe when galaxy mergers were more common. The origin of J1144's extraordinary brightness is still a mystery. According to one renowned theory, the black hole may have eaten a lot of gas after it was made when two very large galaxies crashed into each other. When two black holes are closer together, their orbital speeds go up because they're closer together. This makes the fluctuations more extreme. Up to this point, nearly 880,000 expanding black holes have been identified. People started looking for these expanding black holes in the early 1960s. It's incredible that after all these years, nobody thought of this brilliant concept. The disappearance of J1144 from our skies presumably has nothing to do with its true position. As far as Onken is concerned, the existence of other stars and other distractions in the Milky Way's plane has made astronomers reluctant to examine it. One example would be the fact that several surveys have given up when the search angle was more than 25 or even 20 degrees from the plane of the Milky Way. The beam of this black hole is approaching at an angle of 18 degrees for this light source. A black hole's gravity is so strong that not even light can escape, rendering them invisible to all but the stuff that orbits them. Black holes are very, very powerful forces hungry for energy, according to Dr. Fiona Panther, a gravitational wave astrophysicist at the University of Western Australia, who was not involved in the work. Most of the mass and energy that enters the black hole will be expelled in a huge jet, so a lot of stuff is trashed most of the time. To be more precise, quasars belong to a subset of black hole jets. Almost every galaxy has a supermassive black hole at its center. But as several Australian scientists said, black holes don't have any unique sucking power beyond their gravity's ability to pull everything toward them. This is true even though nothing can escape from beyond the event horizon. If the sun were to collapse into a black hole, Earth would be sent into permanent darkness, but the orbits of the planets around the sun wouldn't alter much since the solar mass would remain about the same. The black hole at the core of the Milky Way is 4 million times bigger than the sun. It's so big that amateur astronomers may be able to see J1144 without resorting to pricey or specialized equipment. To get the best direct vision, astronomers recommend a telescope with a diameter of 30 to 40 centimeters. Grad students found the binary star J1144 while looking for other close binaries in our galaxy. Over the last 9 billion years, this giant has been powering an incredibly bright quasar. Scientists from all across the world collaborated to find this massive black hole, which has a mass of 3 billion times that of the Sun and is constantly expanding to satisfy its insatiable appetite. The gas and dust around the black hole, which make up a thin ring around the object, feed it. This zone is called the accretion disk. The recently found black hole is expanding in size, unlike comparable black holes that ceased expanding billions of years ago, and now that it's 500 times larger than the supermassive black hole at the center of our galaxy, Sagittarius A, it's grown to the point where the whole solar system might fit inside its event horizon. The data led researchers to infer that the newly discovered black hole has developed faster than any other black hole in the last 9 billion years. We need explanations for this occurrence. Christopher Onken, a professor at the Australian National University or ANU Research School of Astronomy and Astrophysics and the study's primary author, has made the following remark. The black hole may have gotten its matter from a huge galaxy crash that spelled out a lot of matter. A black hole's fast accretion of matter results in an immense burst of energy that ultimately shines out as a quasar 7,000 times brighter than the light from all the stars in the Milky Way. If the sky is very dark, you can see the quasar with the naked eye or with a small telescope. During the SkyMapper Southern Sky Survey, the 4.3-foot telescope at Australia's Sliding Spring Observatory saw the black hole. Astronomers have been looking for this for over 50 years. They found several dull ones, but missed the bright one all along. Associate professor at ANU and study team member Christian Wolff claims that finding another black hole forming at this pace or powering a quasar of this scale or greater is very improbable. Wolff said, "It's so massive that there's no place in the universe where this black hole could hide. We're certain that this discovery will stand inside our top 10 by size for a long time." Similar black holes decrease their pace of expansion billions of years ago. As black holes dissipate, they shrink uncomfortably, and their event horizons get closer and closer to the singularities. Our current understanding of how black holes behave falls short when describing their final stages, when they shrink to such a small size. For a long time, it was believed that black holes could not be destroyed because nothing could ever get away from their immense gravitational pull. Recent research has shown that black holes eventually evaporate, sending their energy back out into space. Because of Hawking radiation, black holes are thought to evaporate over time. Although significant evaporation from most known black holes would take longer than the universe's age, it's still possible. Scientists have been hunting for things like this for more than 50 years, the study's senior author Dr. Christopher Onken said. While they had identified hundreds of fainter ones, this very bright one had gone unreported, he claims, and that researchers are wondering what accounts for this black hole's unusual behavior. Did anything horrible occur? He asked. Perhaps the black hole's source of the matter was a catastrophic galactic collision that spat forth a flood of matter. Christian Wolff, an associate professor who worked on this research, said, "I don't think we'll find another one like this. We're fairly confident this record will not be broken," he said. The finding is 500 times greater than the black hole in our own galaxy and has the potential to swallow our entire solar system in a few minutes inside the event horizon. Would you search for this supermassive black hole in tonight's dark sky?